Hi grade 9s, welcome back to another one of our video lessons. So today we're not going to carry on with the textbook theory and work. I'm going to rather talk about the test that you're going to write on Friday. I'm going to go over the sections in the book that are important and that are going to be covered. So for this test, I know it's term 2, but we haven't written our term 1 test yet. So this is going to be a test on term 1's work. And later on in this term, we're going to write another maths test, which will be for term 2. Okay. All right, guys. So as I said, this test will cover exactly term 1's work. So that is from page 4 up to page 81. Okay. So I'm going to run through the textbook talking about the important bits. What I want you to do is take your textbook out, and as I'm going through it, you can mark off the important bits or the things that I think are important, and I am going to ask you these things. All right, cool, guys. So topic 1 is the whole numbers. So on page 4, it basically breaks up our number system into the various components of the numbers. So we have complex numbers, which are real and non-real or imaginary numbers, and real numbers break up into rational and irrational numbers. Remember, a rational number can be written as a over b, where a and b are both natural numbers. Okay, so what I want you to do is basically understand what are these different things. So I could give you a list of various numbers and I say, right, which of these are surds? Which of these are integers? Okay. Or I could say, give me an example of a whole number. Give me an example of an integer. Give me an example of a surd. Okay. Right, remember what a surd is? A surd is a square root of a prime number, meaning that we cannot break that number down anymore. So a surd would be numbers such as root 2, root 3, root 5, and so on. Okay. Right, guys, let's continue. So that was the beginning bit about numbers. Okay, so page 6, page 7 goes through some of these exercises classifying the numbers. So I could ask you something like that. Okay. Using a calculator, guys, for some things you are allowed to use calculators, for some things you are not. And if I say do this without a use of a calculator, you need to show me the working. So that includes addition, subtraction, multiplication, and long division. Guys, you have to know these things. I will definitely ask you those. Okay, so that is page 9, 10, looking at those operations. Now page 11, 12, or rather 11, looks at highest common factor and lowest common multiple. Guys, you must be able to give me those. If I say, here's a number, here's another number, what is the highest common factor between the two? Or what is the lowest common multiple between these three numbers? Okay. The way we do this is we break up the number using our ladder method into our prime factors. And then from there, you pick the right numbers, depending on whether you're looking for the highest common factor or the lowest common multiple. Okay, guys, please go through these examples and make sure you know how to do them. Okay, right, next section 12:13 is solving problems, word problems with speed, distance, and time. So know your speed, distance, time triangle. Remember, the biggest trick here is converting minutes to hours. If I say, John ran 4 kilometers in 45 minutes, what is his speed in kilometers per hour? You need to convert that 45 by dividing it by 60, which will give you 0.75 hours, and then do your calculation. Okay, that is the biggest mistake that people make. All right, then we have some financial maths. Understand what is profit and loss. So profit is your total revenue minus your total cost. Okay, or your selling price minus your cost price times the quantity that we are selling. Okay. Right, guys, word problems are definitely coming up, so go over those. I won't ask you too many word problems, but I'll definitely ask you at least one. Right, calculations with integers, okay, addition, subtraction, multiplication, division, same story. Now you are just multiplying signs, okay. Negative times a negative is a positive, positive times a positive is a positive, and positive times a negative or negative times positive is always a negative. So guys, we're doing the same thing. You just need to now remember the brackets, okay. So I could say that what is the difference? What is the difference in temperature between 3 degrees and -4 degrees. Okay, what is the difference in temperature there? Okay, well, we're going to take one minus the other one. So I'm not going to say 3 minus 4 equals to -1. No, the -1 is not the difference in temperature. We have to count for the double negative. So it's 3 minus, and this number is a -4. So put it into brackets like that. Now, this will equal to minus times a minus is a plus. So it's 3 plus 4, which is 7 degrees. Okay, so the difference in temperature here is 7. We can even see this on a number line. Okay, imagine 0 is here. So we have, okay, other way around. So let's say this is 3 and this is -4. So we have 1, 2, 3, 1, 2, 3, 4. So what's the difference? 1, 2, 3, 4, 5, 6, 7 degrees. Yes. All right, guys. So it's pretty straightforward. Just keep your attention on the sign, or rather, deal with the sign straight away and then do the calculation. All right, cool, guys. So question 20, page 2021 now looks at addition of not just numbers, but also variables. So if we're counting X or Y or Z or whatever it is, okay, so we're adding like terms. Look at the variables. If the variables are the same, and I have 2 of these and another 3 of the same thing, well, it's 5 of the same thing, okay. Right, let's continue. So the next few pages is still more mixed operations in algebra, multiplying our things into brackets, keeping the signs. All right, guys, so more of the same. It just gets a bit more complicated. Now, page 24, 25 is now looking at squares, cubes, square roots, and cube roots. Remember, square and a square root are reverse operations. Okay. So guys, we've done plenty of exponents. So now we're taking integers, we're taking different operations, and we're adding exponents on top of that. Okay. Remember, exponent is like brackets. Treat that first and then go outside. Okay. So if I have -2 cubed, I'm going to first multiply -2 times -2 times -2, get that answer, and then do whatever else I need to do if there's stuff outside the brackets. All right. Okay, so square roots, cube roots, guys, you have to know perfect squares, perfect cubes. It's a common question. So numbers such as 4, 9, 16, 25, they should be standing out for you. And if they're not standing out, you need to find out why they're not standing out. What is so special about these numbers? Also, perfect cubes, which is your 8, 27, 64, 125, and so on. Okay. Right, guys, so that's pretty much page 26, 27. 28 is common fractions and equivalent forms. Okay, so guys, the trick here is the common denominator. In order for us to add fractions or subtract, we need a common denominator. If you want to multiply fractions, there's 2 ways to do it. You either multiply the tops, multiply the bottoms, get an answer, and then simplify that answer. Or you cross cancel if there's, say, 2 fractions that have a common number top and bottom. Okay, so let's say we have 2/3 times 3/7. Okay, what I'm talking about is that 3 and that 3. So that will cancel with that, giving us 2 times 1, which is 2, over 1 times 7, which is 7. Okay. Right, if we have division of fractions, so let's say we have the same thing, 2/3 divided by 1/2. Let's say that's our question. Right, with the division, it's very easy. We change the division to multiplication and we flip the fraction, the second fraction. So this equals 2/3 multiplied by 2/1. And now it just becomes a multiplication problem where we're just going to solve it normally like we did before. Now, if you have a mixed number, you need to obviously convert that to an improper fraction and then multiply. Okay, you can't multiply 2 mixed number fractions together without converting them to an improper fraction first. Okay. Right, let's continue. So calculations with common fractions. So that's just various operations with common fractions. Same thing, we're adding exponents to it, but the idea is exactly the same. Fractions, in order to add the common terms, we need a common denominator. Okay. Right, there's a lot more examples and exercises on that. Solving problems with fractions, so word problems with variables, exponents, and now fractions. So that is our page 34. Okay, let's continue. Then we move on to decimal fractions. Okay, so decimal fractions, same thing as common fractions. How do we go from one to another? Okay, now guys, remember, so decimal fractions works in powers of 10. So let's say I have a number 2.358. Okay, how do I convert this number to common fractions? Well, the 2 is the whole part, which is just 2. The 0.3, these are our tens, hundreds, thousands. So tens, we got 3 tens. So plus 3 tens. Plus, we got 5 hundreds. 500. Plus, we got 8 thousands. Okay, so one way is we can break it up like that. Another way, we could write this number as 2 and 358 over 1,000. Okay, why? Well, let's make these the same denominators as that. Well, how do we get from 100 to 1,000? We add a 0 there, add a 0 there. How do we get from 10 to 1,000? Add 2 zeros. What we do to the bottom, we do to the top. So now we can add all of these together, 358 over 1,000. There it is. And then I can change this to an improper fraction by saying 2 times 1,000 is 2,358 over 1,000. Okay, guys, so you can go from here to there or backwards. Okay. Okay, cool, guys. Percentages are just fractions over 100. Okay, if you want to go from a decimal to a percent, multiply by 100. Okay, if you want to go from percent to a decimal, divide by 100. Okay. Okay, then the next few exercises are on calculations with decimal fractions. Please go over those. I will be asking that. Right, next, simplify algebraic expressions with decimal fractions as coefficients. Okay, so 2.1 plus 3.2 is 5.4. So we add the same way. Guys, remember, how do we add decimals? 0.3 plus 0.25. The idea is that keep your commas in line. Okay, that's the trick. You can even put a 0 there if you want. Then add 5, 5, 0. 0.55. So if we're adding decimals, keep the comma in line, you'll be all right. Okay, let's continue. Okay, more word problems on page 40. Okay, then page 42, 43 is our laws of exponents. Okay, so exponents, understand how it works. How do we work with exponents? What are the different rules of exponents? Okay, remember, as we went this, we had our different rules. We wrote them out. Make sure you guys know what those rules are. Make sure you know how they work. Okay, so that's going up to page 46. Then calculating and solving problems with exponents. Same thing. More problems with now exponents and powers. Well, you know what to do with that. Page 48 looks at scientific notation. So going from really large numbers to small, to writing them in a way that we can read them. Okay. So if I say, what is the mass of the Earth in grams, it's going to be a ridiculously huge amount, which will take me a week to say. But we can write that number in scientific notation, which is quite easy to deal with. Okay, guys, let me show you how scientific notation works again. I know it's been a while, and we don't come across it very often. But basically, we have a times 10 to the power of n. Okay, a is the significant in our scientific notation times 10 to the power of whatever power we reducing or enlarging the number by. Okay, So what do I mean by this? Let's go from scientific notation to decimal and then backwards. Okay, so let's say I have 4.7 times 10 to the 5. Okay, so what we need to remember is that the significant here, A, is a number from 1 to 9. It cannot be a double-digit number, okay, in the whole unit. So it's got to be a 1-digit here before the comma. Okay, so it's 4.7 times 10 to the 5, which equals, well, we're multiplying by 10 to the 5. That's by multiplying by 10 with 5 zeros, which means that we're going to move this comma 5 places to the right. So we have 4.7, we move it 5 places, 1, 2, 3, 4, 5. Comma goes there. Okay, that's 0, 0, 0, 0. And we can erase the line here. So we get 470,000. Okay. Now, if we want to go backwards, okay, what are we doing? Well, we need to have only one digit. Here we have 47. We only want one digit here, so we want to put a comma here. How do we get the comma here? Well, we have to move it how many places? 1, 2, 3, 4, 5 to go there. So it equals to 4.7 times 5 places. That's your n. So 10 times 10 to the 5. Okay, and that's how we go from scientific to decimal back to scientific. Okay, now we can also have really small numbers. Okay, so we're not just multiplying big numbers, we can also think of something really small. So how do we do that? Okay, well, let's work it out. Write the following numbers in order of size in ascending order. Okay, write the following numbers in order. I'm just trying to find the correct example so that you guys have something to look at in your textbook. Alright, so let's look at B, 1B. Write the following numbers in scientific notation. So we did the big one, which I made up. Let's do a really small number. So we have 0.0000000000098. Okay, so this is a really tiny number. It equals to, remember, the significant always puts one digit, comma something. So here we have 98, so we want to have 9, 8. So this will be 9, 8 times 10 to what? Now, if we're dealing with a small number, we're going to get a negative here because we're really dividing this number by all these zeros to get it into such a tiny number. Okay, by how many factors of 10 must we divide it? Well, let's move the comma until it's here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so we need to have an 11 there. Let's see if that's the correct answer. Yes. Okay. Now, if we have to go backwards, you are doing the same thing. So now, since it's a negative, it's a really small number. So we have to move this comma 11 places to the left. Okay, so write your 9.8 and move the comma 11 places, add the zeros, and we'll get that. Okay. All right, guys, then solving problems using scientific notation. So remember on page 50, we did that exercise with the red and white blood cells and then the distance between planets and so on. Right, guys, let's continue. So that takes us to the next section, which is topic 6, numeric and geometric patterns. Okay, guys, remember with this, I showed you the different formula to do this. Your Tn equal to A plus n minus 1 in brackets times D. A was your first term, D was your common difference, and you had to see what pattern the number pattern follows, whether it's numeric or geometric or neither, and apply the correct formula. Guys, we've done plenty of these examples in class. I know you know how to do them, so that's what I'm definitely going to ask you. Also finding the general term, which is Tn. So that's up to page 60. Now the next topic is our functions and relations, so our flow charts and flow diagrams. So you already kind of got used to this section by doing your numeric and geometric patterns and those formula. Here it's kind of the same thing. We're putting an input, we're getting an output. Okay, so that's your page 62, 64, 65. All right, so it carries on for quite a while and we get to page 68. So guys, I think that is where I'm going to stop. Okay, so up to page 68 is what's going to be in the test, and then once we go over this other work that you guys did in the lockdown, and I make sure that you know it, then we'll write another test on that. Okay, so the test will be up to page 68. Okay, or actually including page 69, which is your revision. Okay, guys, good luck, study hard, and I'll see you in the next videos where we're going to continue with the work from the textbook. Cool, ciao.